Hello everyone, my name is Ayush Patil and today I will be performing some experiments. My first experiment will require a glass tumbler, a card, and a coin. First, put the card on top of the glass tumbler and then place the coin on top. Then we will flick the card. But before we do that, what do you think will happen? Will the coin hitch a ride with the card? Or will it fall down into the tumbler? Let's see. It fell down into the tumbler. Did you expect that? For our next experiment, we'll need a toy car. Try to push the toy car with one finger. Can you do it? Now, why don't we try this with the real car? Try to push the real car with the same amount of force as the toy car. Let's see what happens. It doesn't work. Why is that? It's too heavy. For my third and final experiment, I took a string and tied a balloon to it with the help of a straw. Now, to see how this experiment unfolds, I will need to take out the butterfly pin which holds the air together. Okay, so here goes nothing. Oh, wow! Want to see it again? Let's go. Whoa, that went so fast. Did you expect that? By now, you might have already guessed what today's topic of discussion is going to be. Yes, it's Newton's 3 laws of motion. And yes, Newton's 3 laws of motion will help us decode why these experiments turned out the way they did. But before that, we need to learn some simple scientific terminologies.
F equals to force, which is basically a push or a pull. Its unit of measurement is newtons. A is for acceleration, which is the rate of change of velocity, and velocity means speed with a given direction. Its unit of measurement is meters per second squared. M is for mass, the amount of stuff in a body. Its unit of measurement is kilograms.
Now let's return to our original question, which is why did these experiments turn out the way they did? Do you know why the coin fell into the tumbler instead of flying off with the card? It's because it was in a state of rest. An object at rest will always remain at rest unless it's compelled to move by an external force. The same applies to an object in motion. You can experience this in a car. When the car suddenly starts, you move backward, and when it stops, you move forward. This is because in the first case, you're in a state of rest, and you want to remain at rest and you're in the same position. But the car basically drags you forward, thanks to the seat right behind you. The second case, you were stopped all of a sudden, and that means you want to go forward, but the seat belt is holding you back as the car's already stopped. That's why you feel the sudden jerk. This is because of a property in all bodies known as inertia, which is the object's tendency to remain at rest or in uniform motion unless compelled to change by an external force.
So, Newton's second law states that force equals to mass times acceleration. Now, to understand this better, we will rearrange the equation so it says acceleration equals to force divided by mass. This means if the mass is greater, then the acceleration will decrease. So here, a toy car can accelerate very easily because of its small mass, whereas a giant car would not if given the same amount of force because of its huge mass.
This is the exact same reason why in the third experiment, the smaller balloon traveled faster than the larger balloon because of its small mass. This means that it requires a smaller amount of force to accelerate as fast as the larger balloon. So if we give it the same amount of force as the larger balloon, it will travel much faster.
Have you ever realized that a car's tires move backwards to propel you forward? But how does this work? Well, this is explained by Newton's third law. For every action, there's an equal and opposite reaction. So, in this scenario, the tires push the ground backwards and the ground pushes you forward. Since the ground is larger than the car itself, you may not notice the movement of the ground going backwards. But thanks to the reaction of the ground and how small your car is, you go forward.
Well, that's it, the end of the video. I hope you enjoyed it and understood Newton's 3 laws of motion. And I'm Ayush Patil, and I'll see you in the next one.